Today we're going to review from Algebra 1, Graphing in Quadratics in Standard Form. Okay, so you're going to take a look at how we're going to graph a quadratic. We're going to find the domain, the range, and then we're going to start really looking at what end behavior is. So we briefly touched on this last year in Algebra 1. So a quadratic is in the form, standard form, ax squared plus bx plus c. Okay, and of course a can't be 0 or it's not a quadratic. The graph is a parabola. If our a is positive, it opens upward. If it's negative, it opens downward. Our line for our axis of symmetry in this case is that x equals negative b over 2a. And when we go to find the coordinates for the vertex, our x-coordinate is that negative b over 2a. And then we substitute that back into our equation to find the y value or our f of x value. And lastly, c is always going to be your y-intercept. So to graph, we're going to find a, b, and c, find the value of x using x equals negative b over 2a. And we're going to sub in and find a vertex, and then we're going to graph like we did in vertex form, finding other points. In this example, a is negative 1, because remember we always have a number in front of the coefficient. If it isn't there, it's 1 or negative 1. Our b is 4, and our c is negative 7. So that negative 7 is our y-intercept, so I'm just going to graph that right there just to start because I know I've got that point. Now to find our vertex, we're going to do x equals negative b over 2a. So in this case, it's going to be negative 4 over 2 times negative 1, which will give us negative 4 over negative 2, or positive 2. Okay, so our equation for our axis of symmetry is x equals 2. And now I can plug that back into our original equation and find our y value of our coordinate. So y equals negative 2 squared plus 4 times 2 minus 7. So remember, this is the same as saying negative 1 times 2 squared. Okay. So 2 squared is 4 times negative 1 is negative 4 plus 8 minus 7. So that's going to give us negative 3. So our vertex is 2 and negative 3. And it opens down. Now remember, you have that axis of symmetry that goes through here. So you've got points on either side. So I've gone 2 from the line of symmetry here. I can go 2 from the line of symmetry there. Now when we graphed quadratics in vertex form, from that vertex we went over 1 and down 1, and we can do the same there to make sure we have some more points. And if you recall, we went over 2 and down 4, and you can see that this follows that pattern. Your domain in a quadratic of this form is always going to be from negative infinity to infinity. My range is affected by the y value. My y value is negative 3 and it opens down, so my range goes from negative infinity to negative 3. It's included, so you use that brace. Now my end behavior, remember, we look at what happens as x goes to positive infinity, and as my x goes to positive infinity, so we read it in that direction, our y goes to negative infinity. And then as x goes to negative infinity, so the other direction, we're reading it this way, my y is also going to negative infinity. Right, next example, my A is 2, my B is 10, and my C is 13. So that's not on the graph. We can't graph our y-intercept from that. So to find B again, or to find our x value, x is negative b over 2a. So it's going to be negative 10 over 2 times 2, which is negative 10/4 or negative 5/2. So our axis of symmetry is x equals negative 5/2. And then to find our y value, or our f of x, we're just going to plug that in. So 2 times negative 5/2 squared plus 10 times negative 5/2 plus 13. So that's going to give me 2 times negative, or times 25/4 plus 10 times negative 5/2 is negative 25, and plus 13. So that gives me 25/2 plus negative 25 plus 13. And when I simplify that, that gives me 1/2. So my vertex is negative 5/2 and 1/2. So negative 5/2 is negative 2.5, and then up 1/2. Now, since I'm going, I've got a 2, my leading coefficient, I'm going to go over 1 and up 2 on both sides of my axis of symmetry. I'm going to go over 2 and up 4 times 2, which is 8. So we're going to have points here and here. And there is our quadratic. Again, our domain is all real numbers. Our range is restricted. It's going to be 1/2 to infinity. My end behavior, as x goes in this direction, y is increasing. So as x goes to infinity, y goes to infinity. And as x goes to negative infinity, so we're reading the graph in this direction, my y's are increasing, so y goes to infinity. Last example, you know, pre-AP, you got to throw some fractions in there. I'm going to do this down here. So my A is 1/2, my B is negative 7/2, and my C is 4. So if I plug that in, x is going to be negative 7/2 over 2 times 1/2, negative b over 2a. So that's going to cancel. The 2 times 1/2 is 1, so my x is negative 7/2. If I substitute that in, I'm going to get 1/2 times negative, or positive 7/2 minus the negative, squared minus 7/2 times 7/2 plus 4. So I'm going to get 1/2 49 times 49/4 minus 49/4 plus 4. And I'm just going to come up here. That will give me 49/8 minus 49/4 plus 4. And if I add all of that together, I get negative 17/8, which is negative 2.125. So my vertex is going to be 7/2 and negative 17/8. My equation for my axis of symmetry is x equals 7/2. y-intercept is 4. It's not on our graph. So if I graph 7/2 is 3.5. And negative 17/8 is -2, just a little bit less than -2. So right about there. My A is 1/2, so instead of going, I'm going to go over 1 and up a half instead of a 1. We're going to multiply what we go up by each time by a half. So just a little bit less than that on each side. Instead of going over 2 and up 4, we're going to go over 2 and up 2. So just a little bit less there. And then we're going to graph. Okay. So today we looked at how to graph a quadratic in standard form, and here is all of the information that we learned. So have a math-tastic day.